So right now when we run this, we play the game once and so they all shrink, whatever. So I'll make the move there, and that guy just turned to red. That's 0, 1, 2. So we should have a winner there. So right now those guys were all red. Can we move that? Yep. So if I say yes, I want to play again, he doesn't currently play again, right? So the first part of the assignment was how do we make him play again? And I said you could do that in as little as 1 line of code. So what do we start off with? Well, we go back to first method. It says, do you want to play again? And if we do, what do? We say, is it the Mad Hatter that knows how to play? Or is it the scene? The scene knows how to play. So we just tell him to play TicTacToe. So just call that function again. All right. So we'll go ahead and do that. And so now we have 1, 3, 2. Oh, well, I lucked out there. 5, and then 1. Okay, so we should have a winner. Do you want to play again? It's all lowercase, what we currently have, so we'll say yes. And he goes down and he shrinks everybody down to even a smaller size, right? But we can see here, even with the guys that were originally tall, they're shrunk down, but their colors are still the same. All right, so we need to look at how do we change their colors back to their original color, and then how do we make sure that their reset values go down to, you know, or their reset heights go back to, I guess, 100%. So let's go back here. So let's kill this. Exit the running program. So we're going to actually write a procedure of the scene, because that's where our other things are, right? That's where our try to make the move is, all that stuff. So we'll make a procedure called reset monkey kings. All right, and this guy, scene knows about all the monkey kings, right? So we can also probably, well, we'll have it taken as a parameter. So this guy's going to take in a array of monkey kings. Call this MKs. And he needs to go through and set each monkey king, reset their values. Now before we mess with the array, let's just mess with an individual guy. So when we changed his color, well, here's his resize, and we resized it by a factor. All right, we can also set height, set width. So resizing is a factor. So let's do this. We originally shrunk him down by 0.25. So in order to size him back up, what do we need to do? What's the factor? So 0.25 times 4 should resize him back up. And so this is a quarter of his size. So now we want to do it 4 times his size of a quarter, which take him back to his regular size. Or we can just, I don't think there's a way to set his size, is there? I think we still need to resize him. So we'll go ahead and we can actually steal most of, oh, this is for an individual monkey king. So let's just go back to reset. So we'll go down. How do we get to our individual monkey kings? Well, let's just do it on an individual monkey king right now. So we will set this guy's we'll resize him to a multiple of 4. All right, so let's just leave it at that for right now. We'll see if that takes him to the right place. Because actually I want this guy to be a monkey king number, so we'll do that here in a minute, but let's just make sure this puts him back to his original size. And for right, can we remove a parameter? We'll leave it in there. So we'll go back to close check for winner. Here's our first method. So before we play tic-tac-toe again, we need to go ahead and ask the our scene to go ahead and reset the monkeys. So we're going to go ahead and build an array with all of our monkeys in it to pass it as a parameter. All right, and right now that guy should just reset the very first monkey to his right height. All right, so we'll go ahead and run this and test it. So he's setting up the initial board. So we'll go 3. It's running really sluggish. 1, then 4, then 3, no, then 2. How come those guys didn't? That's weird. So he went back to when we did a factor, it seemed to remember that his original size, it knew what his original size was. So we should be able to then we got that. Where's my reset? Oh, there's our reset monkey. So it looks like we can just set that to a resize of 1. And let's go ahead and use our array here. So we're going to create a loop. Well, I'll show you a for each loop here. So for each monkey king, MK in the monkey kings. So this is going to go through every element in our monkey kings. So rather than us having to do bucket 0, bucket 1, bucket 2, so on and so forth, this will go through 9 times, and MK each time through will be the next monkey king in that array. So we don't have access to the index. We don't have that 0, 1, 2, 3 like we had before, but we get all the individual guys. So then what we can do here is we can, let's just copy this, drag it in here, and we'll change this guy to just MK, which is our variable that was part of the loop. And we'll resize it to size 1. And then we'll delete this guy up here. And we'll go ahead and save. And why is it that things were running really, really sluggishly before? Give this the old. Something's not right there. Let's go ahead and Make sure this is saved, and let's restart Alice. Something is zigging when it should be zagging. Okay, that ran a little bit better. So we'll do 0, then we'll do 3, then we'll do 1, then we'll do 4, then we'll do 2. All right, so we're going to go ahead and we're going to say, yes, we want to play again. And we should see the guys shrink down clearly. Why it gets so sluggish? It eventually did it. Let's have him not play TicTacToe again right now. Guess we could just delete that and put it back in. So all we want him to do is reset the monkeys. Here's that function, reset monkeys. This is going to go through each monkey, and we're going to resize it to size 1, and we're going to loop it. That should be fine. We have a, we can give it a duration. We can put it to 0.25 we had before, but I think the default duration would have just been slower. So 0, 3, 1, 4, 2. There's our winner. Do we want to play again? Yes, we do. Why is it not resizing those guys? Is that for each loop not working? Why don't we just try it with this guy for starters? So we'll resize just our first monkey to that size, and for right now let's just delete this. Go ahead and run this. 0, 3, 1, 4, 2. We have a winner. Do you want to play again? Yes. Oh, hold on. That's his original size. When we shrunk everything down. Well, shouldn't these guys have blown back up, though, when we went through? So let's change this guy. This is 0, 1, 2, 3, 4, 5. So we'll change this guy to monkey 5. And we should reset him to his height of 1. The other guys were already a 1. 0, 3, 1, 4. Weird. And then 2. Like, why did that guy disappear? I want to make a move right here. 0, 1, 2, 3, 4. Okay, that worked. Then we'll do 0. We'll do 3. Then we'll do 1. Then we'll do 5. Okay. Why Why is it shrinking down sometimes and not others? For right now, let's go ahead and always reset the monkeys, and we're passing him all the monkeys, but that shouldn't matter because he's actually going in and resizing to size 1, and we're specifically, we can do that in the very last monkey. I don't think that'll make a difference. Why is that not resizing? Okay. Let's change it to a 10. That should be a drastic size difference. One, 4, 2. We have a winner. Yes, okay, so he definitely got bigger in size. But if I changed him to a size of 1, that's the factor, so it multiplied it by 1. So we do need a factor of 4 for those guys. So that would be a custom. All right, so it's going to look like this then. We'll delete this. We'll do our for each loop, and we'll say for gallery type monkey king, and this would be MK in the monkeys. So we want to ask, is he already shrunk or is he his original size? Do we have an original height on these guys? So why don't we tell a let's see if we can ask the question first, because I think we're going to need an actual height of the monkey. So let's just do a whole number less than. We'll do 0, 0 for right now. And that's the monkey's length, but we should be able to go into a monkey and ask him. Maybe we should just keep track of whether a monkey is currently shrunk. So why don't we teach monkey kings how to know if they're shrunk? It's probably a reasonable way of doing this. So we'll go to monkey king. We're going to add a property. Call this guy is shrunk. It's going to be a Boolean. We'll start off as false because he's not currently shrunk. And then when we shrink a monkey, we're going to go ahead and set that monkey's set shrunk let's see. Oh yeah, we're resetting everything to true. So when we shrink them down, we negate who moved them to -1. We shrink him down. We let him know he's shrunk down, so that back here in reset monkey kings, we can ask the question if, and we need to change this guy. Go ahead. We could do this off who moved me. If it's equal to -1, that means he's currently shrunk, therefore switch him back. Otherwise, we can do the is shrunk. Their equivalents, putting a variable in for is shrunk, I think from a verbosity makes sense, just to say, are you currently shrunk? This if statement is going to look cleaner than is who moved me equal to -1. That we know it means the same thing, but I don't know that that's necessarily going to be clear for us from our programming thing, but it will be the same value. All right, so we'll say something equal to something, and we want to ask the question if, actually we're going to be able to say true. Looks like we need to do a Boolean. So actually we can just drag the whole thing in there. So we'll ask about mk. If mk.get shrunk, just replace this entire thing with that. If I'm currently shrunk, then I need to quadruple my size. So I will resize by a factor of 4. Else, if I'm not currently shrunk, I don't need to do anything, but we'll be verbose here. Just say we'll resize by a factor of 1, leave it alone. We'll just not do anything right here would be the alternative. Okay, so if he's not shrunk, that means he's already the right height. So this should now reset it, I believe, in terms of height. We're not dealing with all the variables yet. So let's run this again. All right, and so we'll make it go 0, 3, 1, 4, 2. Do you want to play again? I don't think it matters how I answer right now because I have it outside of there. Oh, when I click them, I don't set the shrunk. There, those guys go back to normal. When we make a move, we need to set is shrunk equal to false. Was it try to make move? Okay, well, actually, let's just make move. I thought we tried to make the move before. Didn't we have a try to make move that we're actually calling? Let's look at TicTacToe. Yeah, we have try to make move, which is of the scene. There it is, it's a function. So try to make move finds out whether they're allowed to make a move. If they are allowed to make a move, then we need to go ahead and we need to set the monkey. We need to set his shrunk to false. He's no longer shrunk. All right, so now whenever we shrink them all down, their shrunk becomes true. Whenever we make individual moves, their shrunk becomes false. Then when we go to resize them, and reset monkey kings, if get shrunk is currently true, that means they're tiny. We'll go ahead and blow them up. Otherwise, we'll leave them at 1. Now this should reset it. 1, 4, 2. Go ahead and say yes. There we go. All right, so they all shrunk up or reset to the right size. All right, so now we need to deal with their color. I'm guessing here when we resize them, we should do a duration. Otherwise, it's going to take forever like that. All right, so now we also need to deal with their color, and they all should go back to their original color. So how do we get their original color? Let's look at this. Okay. Do we have like a reset color? We have set paint, and paint has a color. Do we have a get paint? We have a get paint, so we're going to have to remember our original color in order to reset our original color, unless there is a reset paint. It doesn't look like that. All right, so we'll teach each Monkey King. Give him a property. Original, well, let's call it original paint to match their variable name. And this guy is going to be a other type paint. And, well, we're going to reset it to something else here in a Alright, so when we first reset the monkeys, or we first bring a monkey into existence, I guess, we want to go ahead and, let's see, all the monkeys are coming into existence in the first method here. So what we want to do is probably give ourselves that array. So we're going to create a variable up here. And we'll call this guy the Monkey Kings. We'll use this to pass into our different things. And this guy is going to be a gallery type Monkey King. And he's going to be an array. And we're going to start it off to a custom array. And we'll put all of our individual monkeys in here, just like we did before. Then we'll pass this guy around. There's our monkeys. Then we can go ahead and do a loop here. So we're going to go through and say for each Monkey King, MK in the Monkey Kings, we're going to tell that particular Monkey King to remember his starting color, or starting paint. So we're going to set original paint equal to, I'll just put a color in there for right now, equal to get my original paint. So now this guy should remember his original paint. Every monkey now knows their original color, which should then, and I'm going to pass in the Monkey Kings there instead of creating the array twice. So I created the array one time, we went through the whole array at the beginning and told each monkey to remember their original paint. Then when we called TicTacToe the first time, when we played, paints could possibly change. When we call reset monkeys, we'll come back into here. We're going to go through, we resize everybody appropriately, and then we also need to set each monkey's paint. So regardless of what size he originally was, we're going to set his paint back to his original paint. Well, that has a duration as well. I guess we'll put that as 0.25. I don't know how long it takes them to paint a monkey. Alright, so I'll go back to my first method now. So we'll go ahead and drop reset monkeys inside of our, whether we answer yes or not here. And then we'll also go ahead and call our play TicTacToe after reset monkeys. We'll go ahead and run this. So 0, 3, 1, 4, 2. Played our game. We have a winner. Do you want to play again? Yes, I do. So we went ahead and reset all the colors. They're all back. And now he's going to set up our board, and we just play the game another time. So we'll win on the second row now, let's say. So that'll be 3, 0, 1. Let's see, did we reset? Yeah, they got reset to -1 for who made the move. Oh, that's not the direction I wanted to go with that. Oh, illegal move. 4, 2, 8. So we should have a diagonal winner. Now he should ask me if I want to play again. Oh, we only asked once right now. Okay, so finally, this is our logic for determining if we should play again. Well, here's the question, here's the logic. So we want to continually put this inside of a loop. So while true for right now, we're going to ask the question. We're going to respond like this. And then we probably need to have a variable that gets flagged. So we're going to have keep playing beforehand. Do this a bunch of different ways. So keep playing is going to be a Boolean. And we'll start this guy off at true because we do want him to ask the question at least one time. And so there's that. So then we're going to say while keep playing. So that's while keep playing is equal to true. What are we going to do? We're going to ask the question. We're going to play. Then we're going to, if they say yes, we'll go ahead and play again. Otherwise, we'll say see you. Now, what we need to do is if they say yes, we want to assign keep playing to true. So now the very first thing we want to do here inside this loop is we want to play TicTacToe. So we'll play TicTacToe once. We'll ask the question, do you want to keep playing? If yes, we'll set keep playing to true. If no, we'll set, we'll say see you, but we also need to set keep playing to false. Go ahead and delete that line. So now, everything we do is all inside this loop. We start off by saying keep playing is true. So we'll do this at least one time. So while keep playing is true, play TicTacToe. Ask the question. If they answer yes, we'll set keep playing to true. It was already true, but we'll set it to true anyways, just so we see it. Then we'll reset the monkeys. Then we let the loop naturally reset, and we'll play TicTacToe again. So this will keep us playing over and over and over and over again. All right, so we'll play one last time. Okay, we played once. We have a winner. Do you want to play again? Sure, we'll play the same game again. And then we'll say no. All right, so we'll do 0, 3, 1, 4, 2. Do you want to play again? No. See you. So now we should be done. Make sense? So, reasonable approach to doing it. As he pointed out, we could have reused some of our own variables. Nothing wrong with reusing old variables or dual purposing a variable, which is what you effectively did, right? You said, well, whether or not a move was made tells us whether or not I need to reset this guy's color and stuff. Fair enough. But it also relies on you knowing what that -1 meant. If you're the only programmer who is writing it, not the end of the world. But more times than not, I think it's worthwhile using the extra variable that says what it means. Okay, eventually, if you're doing a little throwaway thing, don't waste a whole lot of time creating a zillion variables, but certainly when we're learning, we want to do that. Okay, so now that we've done this the Alice way, what we want to do is we want to go and look at the equivalent of this in Java. Okay, and we're going to build this using the same logic that we had here in Alice, where the scene had most of the functions, right? And then we had the Mad Hatter guy that did some asking questions and stuff. But really, the Mad Hatter was only needed because we had to have that some level of communication with the player, because the scene isn't allowed to talk to the player, right? Well, actually, I think can the scene ask questions? It might be able to. I didn't consider it, but whatever. No, scene has procedures. We can play audio, but huh? It has functions. Oh, we get Booleans from user, but we can't say anything. That's the issue. That's what we couldn't do. We could ask the user for input. Oh, we can give it a message. Yeah, so we could have done it from the scene. We could have avoided the Mad Hatter completely. So we'll do that in Java, but that was really the purpose we put them in there for, is for the communication with the user. All right, so let's go and look at a Java version of this. So we're probably going to take a couple of class periods to do this, because while we write a little Java, we're going to connect it back to Alice and see what's the equivalent we're writing here. All right, so what we're going to do is I'm going to open up a tool here that we're going to use for writing Java. It's called Eclipse. And I'll show you where you can get this. This is eclipse.org is the website for this. Works for Mac, PC, Linux, you name it. I assume does the internet work? Yeah, there we go. It's just slow. All right, so once you come to eclipse.org, go ahead and click download, and you can do the Eclipse installer or whatever, or the one you want is Eclipse IDE for Java developers, this guy right here. Okay, the Java EE developers one actually probably would work, but this is the one we're going to use, Eclipse IDE for Java developers. All right, and it should automatically select what your platform is, Mac OS X or Windows or whatever. All right, so you'll download that. I'm not even sure if I have the absolute newest, latest, greatest version, but they'll all look pretty identical to this. I think I do have the newest one on here right now. I have Luna is the current version, and what does it say it is out here? Who knows? Whatever, I think I have the newest version. All right, so what we're going to do, and I'm going to try to use as many words that match up to what we're doing in Alice as possible, because one of the things we do in this class is we use a visual tool to kind of teach us some of these programming concepts. And the purpose of that is to segue us into using actual syntax, which after you get over the hump, I think you'll find it's actually easier. Alice is meant to be easier, but kind of handcuffs us in order to do things a very specific way. All right. So once we're in Eclipse, when Eclipse first launches, it's going to ask you where do you want to store your projects. You could pick any place on your computer. It also suggests a default place. So if you're okay with the default place, just hit OK. Otherwise, I keep all my projects in Dropbox. That way, everything gets backed up automatically. But wherever you want to store it, that's fine. So once you're in Eclipse, you'll initially not see anything over here. These are all these different projects that I'm doing in different classes. So I'm going to go ahead up to File. I'm going to say New. I'm going to say Java Project. All right, and we are going to call this guy TicTacToe. Okay, so that's going to be my project name. And everything else I'm going to leave alone. I'm not going to touch anything else. We're just going to hit Finish. All right, so now I have this project TicTacToe over here on the left. If you double click on this, you see that you have, here's a Java runtime environment. So this is the Java virtual machine that knows how to run your program. We're not going to touch that. Then we have this folder called source that currently has nothing in it. Okay? So we're going to right click on source and say new class. So anytime we build an object in Java, it's going to be a class. We talked about that in the transition from C to C++. All right, so we're going to build a class, and we're going to name our entry point class scene. All right, that's what we're going to name it. Typically, I name it driver because it drives the program, but we're trying to connect this to Alice, so we're going to call this guy scene. All right, so we'll just name this file scene. We don't have to do anything else, and we'll hit finish. All right, so we get this blank file like this. All right, and then what I'm going to do is, again, to connect this to Alice, we have something called myFirstMethod. We're going to write that here in a second, but so this is the empty skeleton of any Java program that you intend to run. You have to have this method, this function. So by Alice's definition, this guy would be a procedure because he does not return a value. His return type is void. So in Alice, this is a procedure. In Java, we call these all methods. All right? So in any case, it must always look like this. The one thing we can change is we can change args to be something like elephant or whatever we want. So this is for command line arguments, which we're not going to talk about right now. We're not going to use them right now, but that's what it's there for. So this is just part, as far as we're concerned, this is just part of Java's required syntax. Okay? So always write main this way. And then for starters, just to get everything rolling, we usually start with our hello world program. So we'll just do system.out.println. Hello world. And once we have that in there, so this is how you print something to the screen in Java. System.out.println hello world. All right, so I'm going to go ahead and just hit play up here. And that's going to do all the magic behind the scenes to compile the program, talk to the Java virtual machine, tell it to actually run the program. And we get hello world spit to the screen. Make sense? All right, so to connect the dots here with our Alice thing, in Alice, our very first procedure here was called myFirstMethod. All right, so we're going to go ahead and we're going to create a procedure void myFirstMethod, and we'll have this guy actually do the hello world, and then myFirstMethod actually get called from there. All right. Complete waste of time, but mapping up to exactly what Alice is doing. All right, and if we look at Alice here, we'll see if we go back to our scenes. Is it perform custom setup? Is that where it's at? No. Oh, that's for pre-stuff. That happens before we even start. Initialize event listeners. Yep. So right here, this is effectively Alice's main method. This thing called scene activated. Okay. Unfortunately, because Java is a language that's a derivative from C, which is a derivative, well, languages derives from C++, which derives from C. Main came with it. If we look all the way back at an old school C program, let's see, let's just go here. Let's open another tab. We'll probably have a test.c probably that has, yeah, there we go. So this is a old school C program, and hello world in C would look like that. So there's our hello world in C, and I'll go back in and we'll look at the syntax here. So notice, way back when we had a method called main. except this predates methods. So actually in C, because it was originally made for writing the Unix operating system, this guy would actually be a Alice function because it returns a value. Okay, this guy says I return an int. So methods, functions, procedures, they have a name. They have a parameter list. So that's, this guy takes in 2 parameters. And then they potentially return something. All right, we're not going to get too caught up in that this exact moment. But for right now, that's where main comes from. So we're going to have to mentally connect the dots between Alice and Java, where we say scene activated is equal to main for us. All right, and then we'll go ahead and call my first method, which is right here. We're calling my first method, and there's my first method. Okay, so that's that guy. Now, if we look at Java pretty carefully, notice that they're using, or Alice carefully, we use the word this pretty often. All right, so what's actually happening in Java, so if we want to, or in Alice, if we want to connect the dots exactly here, what we'll actually do is we're going to actually create a second object. We'll create a scene object, and that scene object will have a function in it, or actually a procedure, called scene activated. And that scene activated procedure will then call the procedure called my first method, which then goes and does some things. All right, so we can kind of mock that up next time to make it match, but as a starting point and for your homework for Friday, go ahead, download Eclipse from eclipse.org, get it installed, make sure it works, and there's tutorials up there that you can follow. On the Mac, you just drag it in. On the PC, you double-click, it has an installer, so it shouldn't be a big deal to get it installed. And then effectively go in and get a hello world program working. So either write it like this, or you can just put it all in main, whatever makes you happy. And then when you run it, you'll get something that looks like this. So what I want you to do is give me a screenshot of your Eclipse working. That way I know you have that working, and we're going to spend the next several classes doing some back and forth. Questions, comments, concerns, bribes? All right, I'll see everybody on Friday.